So hopefully you've written down this example already in your notebook. Again, this is Module 21, Objective 21.3c. Last one in Module 21. Notice that both of these say solve. When it says solve, the majority of the time, almost always with these quadratic equations, you need to have equals 0. Do I have equals 0 in the first one?
Yes.
Okay, so we're good. Okay, the next thing that we're going to do is we're going to factor. Now, how we factor is different from problem to problem, but almost always you want to check to see if there is a greatest common factor. Is there something that I could factor out of each one of these? I could divide by more than 2. I can divide by 4. And actually, I can divide by x because this one does not have an x attached to it. Had it had an x, then I could divide by it. But I can divide by 4. So I'm going to divide every one of these terms by 4. So that would be 4 on the outside. X squared minus 2x plus 1. Okay, that's factoring it. Now, technically, when we are solving, not factoring, when we're solving, is the 4 going to be important?
Yeah.
If it had an x attached to it, it's of importance. And you're going to see that in the next problem. But in this case, the 4 is not important. 4 is not important. So I don't even need to have it be a part of the problem. I just divide it off of 4, and it's gone. Now I just have x squared minus 2x plus 1 equals 0. This is actually, all of a sudden, a 21.1 question. Objective 21.1. Because really, you can go straight to the box, put in the x squared top left, 1, bottom right, multiply the x squared and the 1. That's what I want these two terms I'm about to come up with to multiply to. And then I want them to add to negative 2x. Can you think of two numbers that will multiply to 1x squared that will add to negative 2x? Yeah. Negative 1, negative 1 works. Okay, negative 1, negative 1. Now, keep in mind, you're going to have x's attached to these. So it's negative 1x, negative 1x. Yep, when you multiply them, it's a positive 1x squared, right. So negative 1x here, negative 1x here. Now I'm going to take the GCF of the top row, the biggest number I can divide by. I can divide by a 1, really, that's the most. But I can also divide by an x. So I'll divide out a 1x. So 1x is on the outside right here. I know 1x times a 1x is 1x squared, or x squared. I know x times negative 1, negative 1x, and x times, hey, negative 1 is negative 1x. So factored, I have technically x minus 1 times x minus 1. You could rewrite this if you wanted to just x minus 1 quantity squared. Not really all that important. The next step is to set those things that are multiplied together equal to 0 and solve. Now, each one of these is exactly the same. That's what's different about this objective versus 21.1 or 21.28. That's the only difference. Is that when you set them both equal to 0, either one of them is going to give you the same answer. So if I said x minus 1 equals 0, and I solve, that means to add 1 to both sides, I get my final answer for the first problem. X equals 1. That's it. That's how you do the very first problem. Let's go to the next one. Again, with these quadratic expressions, it's best to have equals what? You need equals 0. Okay, so I'm going to move that 16p squared that's on the right side, I'm going to move it to the left-hand side. I'm going to add 16p squared. Now it happens to be something that I can put together with another p squared. I have a negative 25p squared on the left side, and I'm going to add 16p squared. So that's 4p to the fourth minus, well, because it's negative 25 plus 16, I get minus 9, right? Minus 9p squared equals 0. Question was, is it to the fourth power? When we're adding or subtracting, we don't add the exponents. It's only when we're multiplying that we add the exponents. All right, so we have 4p to the fourth minus 9p squared. Before we do anything else, very first problem that we did, we checked to see if there is a greatest common factor. What is the greatest common factor for this problem?
No,
1,
8.
but more than that.
8. 1, 2, 3, 4, 5, 6, 7, 8.
No, it actually isn't. It is not a number.
It's a letter X.
P. I can divide by actually more than P.
P
P
squared.
squared. I can divide by P squared to each one of these. The smallest number of P's that I have a part of this problem right here is a P squared. And there's a P squared, at least, from each one of these terms. So I divide out a P squared. That means P squared equals, P squared on the outside. I'm factoring here. P squared and 4p to the fourth divided by p squared is a 4p squared. And a p squared divided by a p squared here, that's just going to cancel out. All I'm left with on this is a 9 equals 0. So I factored out a p squared from this problem. Inside the parentheses, I have a 4p squared minus 9. This is just like the previous objective, where we only have two things. There isn't a p term. These numbers will act like my first and my last, and 0 will be what I'm trying to add to. So let me erase this part right here so I can put together a box. The p squared will be something that I use in a minute, but the 4p squared minus 9, I'm going to try to factor. 4p squared right here, negative 9 right here. Remember, I'm multiplying these two numbers to find out what it needs to multiply to, or what these two terms multiply to. That's a 36, or negative 36, p squared. Yep, 4p squared times negative 9. And I want them to add, so like I said, 0. What do you got? Yep. It's got to be negative 6 and a positive 6. Remember, they have to be exactly opposite, of course, with the p's, like what was said. So negative 6p, positive 6p. Negative 6p, positive 6p. I'll put the 6p here and the negative 6p there. Doesn't really matter where you put what. Okay, what is the greatest common factor now of that top row?
Oh, P, 2, and 9.
Okay, I like the idea of dividing out a p,
Wait, is that?
but it's more than that. What's the
it's-
top
it's-
row divided
is
by?
that a 9?
Okay, I got it.
Oh, that's 4.
That's a 4. That's a 4.
Oh.
Yeah, that's a 4.
So
Yes.
Okay, the top left right there. Like where 4P is.
Yep.
Yeah, no, the one above.
This
That
one?
would be 4P, yeah.
Okay, can't put a 4, can't divide a 6
Oh,
by
yeah,
a 4.
yeah,
I can divide here by 2p.
Oh.
yeah.
Okay, hopefully that's what you were thinking.
And then to another 2.
And yeah, 2p times 2p would give me 4p squared. 2p times
3.
3 would give me 6p. 2p times a negative 3 would give me negative 6p. So factored for this problem, I have p squared on the outside, a 2p plus 3, and a 2p minus 3. That equals 0. You remember, hopefully you remember, the previous problem where when we divided by a 4 at the very beginning, it wasn't important because it didn't have the variable. With this problem, this p squared that I divided out, the GCF, it is important because it has the variable. So I'm going to set p squared equal to 0. I'm also going to set 2p plus 3 equal to 0. I'm also going to set 2p minus 3 equal to 0. And I'm going to solve each one of these to get my final answers. For this problem, what squared would give me 0? What value, if I squared it, would give me 0? Only 0. Okay? The only thing that if you squared, you get 0 is 0. P equals 0 for one of the answers. The other one, first thing we would do with this one is subtract 3. That's 2p equals negative 3 and divide by 2. Negative 3 halves. Now you could say negative 1.5. I would accept that as well. Either one. For the other one, add 3. That's 2p equals 3. Divide by 2. P equals 3 halves. So your final answers for the second problem are 0, negative 3 halves, and positive 3 halves. And the first problem's answer, again, was 1. So all those, make sure you get down on your do now sheet. I'll be collecting do now sheets at the end of next week. So make sure that you have them all caught up.
Wait, why next week?
That's the end.
Oh, it is?